Yes, thank you so much for showing up. Thank you so much for the invitation and for having me. So I'm going to talk about 20 years of domain-driven design and about what I've learned about domain-driven design. And yeah, I was already asked what domain-driven design actually is. So here is a short overview about some techniques that you could that belong in the DDD area. And I've created a slide where it goes to more details from left to right. So the least details we have in big picture event storming, where we just use stickies with events to understand the domain and what is going on in the domain and to find bounded context, which I will talk about later on. Then we have the core domain, so that's one part of what we can discover in event storming, and that's the focus of the project. Then we have bounded context, where we talk about bounds for a domain model and also ubiquitous language, so I will talk about that later on. We have strategic design to decide about the collaboration between different teams and different bounded contexts. And then we have the more fine-grained parts, which are design-level event stormings, where we have commands, systems, and so on, in addition to the events that we have in big picture event storming. And finally, technical design, where it's all about classes, entities, aggregates, and so on and so on. And in this, so as you can see, there are quite a few techniques that you can use in domain-driven design. And the goal of this talk is to give you some personal spotlights about things that I think are interesting, that I learned, and that, well, make me want to do more stuff with domain-driven design. And I want to start with something that is actually quite personal. So that's something that happened in 2007, which is pretty much 20 years ago almost. And we organized a workshop with Eric Evans at that point. So Eric is the original author of the domain-driven design book. So he is the person who actually invented this whole thing and got it started. And I thought we would be talking about classes, how to build object-oriented systems. And I was sitting there, and the first statement that Eric made was, well, if we have some software product, some software project, then not all parts of the system will have the same quality. And this is, on the one hand, trivial, but on the other hand, this has some implications. And the implications that he made and pointed out were that you just have one choice. Either you let that quality happen by chance, so you just say, okay, we are going to build that system, and I'm not steering the quality, I'm not setting any priorities, or I actually steer the quality and I set priorities about specific parts. And I think this is a very simple but powerful statement in a way, because there are people who say, well, we have to have the best quality in all parts of the system. And while this sounds like a good idea, it's actually not. It's like saying everything is very important, so please do everything at once and do it tomorrow. If we want to set priorities, we have to say no more frequently than yes. So therefore, we have to set priorities and say, this is what is really, really important. This is what matters. And this leads to this pattern of core domain that I already spoke about. So not all parts of the systems are going to be equally well refined. They won't have the same quality. Some parts will be better, some parts will be worse. So you have to set priorities. You have to have a very boiled down, simple model for the core of your domain, that what really, really matters. And this is why it's so important to find the core domain. And as I said, this is actually not as trivial as it seems, because there used to be this idea of extreme programming, where people actually said, well, we have to aim for the highest quality in everything, and we have to make no compromises. And basically what this pattern in a way says is, well, if you do it that way, then the quality will just be randomly distributed all over the place, and you're actually not setting any priorities at whatsoever. So the lesson learned to me is DDD is more than just a set of rules to develop code. This is what I originally thought we would be talking about, classes, object-oriented design, and so on. It's actually a holistic approach to software engineering that covers a lot of different things. And that is why I gave that first overview where there were so many techniques to show that there is a lot of stuff for different areas, which means DDD is different things to different people. So if we look at this graph again that I've shown in one of the very first slides, what I thought we would be talking about is tactical design, where we talk about, classes and object-oriented design. And we ended up talking about this. And if you are a developer, maybe, on the code level, and this is what you deal with, maybe tactical design is for you. If you're more like the architect type of guy that I think I am, then you're probably more on this side. And therefore, I think this is quite interesting. It was pretty much an eye-opener for me. So the question becomes, well, what to focus on? And I had several conversations of this nature where there is a client. So I do architecture consultants. So some client comes to me and says, okay, we are going to migrate our system to domain-driven design. What do you think about our approach? And the answer is basically, well, looks good, but what's the value for the customer? Because at the end of the day, if you don't provide for the value to the customer, then the question is why you are even being paid, right? At the end of the day, it's about the value that you generate for customers and users and so on. And obviously, one answer could be that you can actually change your software quicker, but that's not a value. That just enables you to build features that are valuable. If I use some kind of software, I don't care whether it's changeable or not. What I care about are features. So if you just have a way to provide features, but you don't actually provide features, then your software is not really that much valuable to me. So again, so basically the question is still open. So what's the value to the customer? And the answer is, I don't know, because the software just becomes changeable, but the features stay the same. And I think we are missing something here, because what domain-driven design actually says is that the domain should drive the design. So the value to the customer, I think that's the domain. That is why domain logic is so important. This is what should drive the design. This is why it's called domain-driven design. And this is also what should drive the migration, obviously, in my opinion. So if you say, okay, we're going to migrate our system to domain-driven design, but you're not really providing any value for customers, what's your point? Why are you even doing that? And there are other stories of a similar kind, so where they say, we do domain-driven design, so we do tactical design, we do event storming. And the question to me is, when have you spoken to a user the last time? And the answer is, well, maybe a year ago. What do they want to have changed in the system? What should be improved in the system? They are happy as it is. Well, I have a hard time believing that, because any piece of software that I use, I have at least some ideas how they could be changed. I'm not saying that they should be changed in that way, but I do have some ideas. And maybe if you talk to another user, they have different ideas. But it's very unlikely that you talk to a user and say, well, do you have any ideas about what should be improved? And they say, well, I have no idea whatsoever. I'm just using the software and it's great. It's great all over the place. And this means that you're missing the point. The domain cannot drive the design if you don't talk to customers, because you don't know what the domain actually is. And this is so very important, because it's called domain-driven design for a reason. The domain should be the focus of your development. And that, in my opinion, means you should generate value to customers. And that means you should be talking to customers and domain experts, because otherwise you don't know what they actually want and what it is that you should be building. Which means you can use all the patterns that I gave on that very first slide, and you still gain no value for customers. So I have one special service for you. So I've created this, I think, nice looking slide. So you can just print it out, hang it over your, I don't know, your desk, to make sure that you look at it all the time to understand that the domain, the customer, value to the customer should drive the design. This is what matters, and this is what is so very important. Now, the question becomes, who actually does this? In the sense of, well, I'm a technical person, I have no idea about banking or whatever it is that the domain is that the system is created, that the domain the system is created for. So if it's banking, I have no idea about banking, and it's probably the same for a lot of other domains. So the question becomes, how can I even build systems in a domain-driven fashion? And Eric, in the original book, which is pretty much 20 years old, said that domain-driven design is knowledge crunching. So there is this term number crunching. So you have supercomputers that do number crunching and do these very complex calculations to come up with a weather forecast, for example. And what we do as developers and as technical people, together with domain experts, is knowledge crunching. So we have some knowledge that the domain experts have, and we crunch that until we finally get software. Which means we need to have customers, domain experts, we need to have a development team that actually understands the domain, and so on and so on. And often they are not really interested. So I didn't study computer science to understand banking. I studied computer science to understand computing. So there is a problem there. And people who did banking and are educated in banking are probably not that interested in software. So there is sort of a natural gap there, which means that collaboration is often hard. And also for the reason that we as engineers live in different parts, live in different worlds from domain experts and our customers. So the question becomes, how do you actually engage with them? And this is where I wanted to spend a few slides to talk about event storming. So in a way, event storming is very simple. It's an event that happened in the past, and we have at least a noun and a verb. We have the verb in the past tense. It's something that happened. We write that on an orange sticky. For some reason, the colors are very important, so you're doing it wrong if you're not using orange stickies for events. And this becomes the foundation to find a good domain architecture. So here is one event. It's the order accepted event, which means that the customer has submitted the order, and now we accepted the order, and we are going to do invoicing, and we are going to do the delivery and these kinds of things. So this is the technique that I want to talk about. And if you do that, then you end up with, well, lots of stickies on a wall or in some Miro board or whatever it is. And I think oftentimes as developers, we care about the artifacts. So it seems that what we've created here is very important because it's an artifact that starts the design. But I think this is sort of missing the point, because what we really have here is something that is truly collaborative. There is the term collaborative modeling, and event storming is one of the techniques for collaborative modeling. And the reason why this is something that is truly collaborative is because there is a very low barrier. You just have to write a sticky, and all you have to know is there should be a noun and a verb, and the verb should be in past tense. So that is something that is not so hard. It's not as hard as doing some formal stuff in BPMN or doing some coding. It's informal, and quite a few people should be able to do that, which means that anyone can participate. And there is also a way to easily do stuff in parallel. So I just passed all of you some stickies, and we just go ahead. We use that wall over there, and we stick events to the wall. And we could do that with quite a large number of people, and therefore it's quite different from a meeting where there is one person standing in front of a crowd and doing something, right? It's truly parallel. People are actually truly involved. And there are alternatives. So this is just one technique of collaborative modeling. There is also domain storytelling, for example. And it's called collaborative modeling for a reason, because it facilitates collaboration. This is why it's called collaborative modeling. And I think there is something to learn from that. So what I'm doing right now, it helps you to understand what I'm thinking and what I want to give you as some knowledge. But there is hardly anything coming back. This would be different if we had a Miro board or some stickies and we could work in parallel, Then we could have a common model and we could work together, and that might already be a help. So, if we were doing some design session now, and I would be staying here and saying, okay, we're going to do this, this is much less of a collaboration compared to when we all use some Miro board or we use some stickies. So using these tools and actually working in parallel and having this low barrier, I think that's helpful. There is also another low barrier here. I mean, if you use some stickies, you just write some sticky. If you have a question right now, you would need to raise your hand and ask it. So that's a quite different barrier. So the lesson learned is collaborative modeling actually facilitates collaboration. What a surprise. And I'm not sure whether the artifact that we generate, this huge thing where we have all the events, whether that is really, really so important, or whether the process is also important, because during the process we understand who knows what, how people actually collaborate, and so that means we know who to talk to if we have some specific question about some specific part of the process, and we know how the people usually collaborate. And collaboration, how people interact, I think that's the main challenge that we have in software development. It's not about the technologies, it's not about programming languages, it's about collaboration and how people interact. So therefore, this might be helpful. Now, there is another subject, and as you can see, I'm a little bit, how shall I put it, afraid of it, and that's bounded context. And in a way, bounded context is easy, because it just means that we have a limited, bounded, context, where there is a domain model that is valid, so some code, and a ubiquitous language. So ubiquitous language that is in the code, in the database, and so on. That's a very abstract, that's an abstract concept, so we should make it more concrete. So I would argue if we want to build an application for e-commerce, for example, we start by some functionality. So we start by invoicing. So there is some black box, and we put in the order and we get out the invoice. And then there is the VAT calculation, and we put that in the same box. So now we have a box that creates invoices as well as VAT. So that's the text that you have on the invoice. And some of you would say, well, that's a stupid idea. We should have to separate things that do that. And that's fine. That's an architecture decision. I decided it this way. You can decide it differently. But we want to have that discussion. So I decided that this is the invoicing process, and we have that stuff in there. And tracking is something that is different. So to know where the order is very different from creating an invoice for it. So we built a different model. It's a completely separate piece of code. And we also have the algorithm in there that says if you want to ship that laptop here to the customer, this is how we are going to do it. So it's not just tracking, where is the package, but also how are we going to deliver anything to the customer. So that's the shipping bounded context. And finally, there is the shopping cart and accepting the order, and that becomes the order process. If we stick to that example, then we have a customer that will pay that bill. So we have a customer with a billing address, and we have a product with a price, and this is what matters for doing the invoice. While for shipping, we have the customer that we ship something to, and the product, well, the size is important, right? Because we want to figure out how to get it to the customer, so the size and the way and so on, that's important. And for the order process, we have a different model yet again, where we talk about the product preferences of a customer or marketing information about a product. So we have different models with different aspects of specific parts of the system. And bounded context is, I think, very important because it's one of those core patterns of domain-driven design. So if you look at the original book, there is a mind map of all the patterns in domain-driven design, and bounded context is one of those central patterns. And it's a limited context in which a ubiquitous language is valid. It is a way to build specific models for the domain, but it's also supposed to be the scope of a team. So that's the third thing that this is supposed to be. So actually it's three things. It's the ubiquitous language, the domain model, and the teams. And I want to go through these three different aspects. So the first thing is about the model. So the focus is the business logic, right? So we have the business logic here for invoicing. So this is where we figure out how much money the customer needs to pay and these kinds of things. We have different business logic over here where we figure out how to get stuff to the customer and so on and so on. So that's something that I'm very interested in as a technical person, because now we have three different parts of the system, and this is original software architecture, structuring the system. With the ubiquitous language, well, in invoicing we have a term like invoicing that we probably don't have in shipping. We have terms like shipping there. So actually the language is different, but it becomes more interesting because here the term product, well, there is a price for a product, and here it's more the weight. So you could argue these are different products in a way, right? And then there is the team aspect. So this is supposed to be something where we have three teams, and I don't know why. Because, I mean, I could have one team implement everything of this if it's easy enough. So I'm not sure about that one. So what's the advice here? So to me, the natural focus for technical people like myself is to split the system apart in different parts, different coding parts, different models. The ubiquitous language might help. So we figured out that the product is different in each bounded context, so that might help us to separate things in code, because we actually notice that specific terms are, well, differently defined in the different bounded contexts. I don't think it makes any sense to be very strict about that one team should only do one bounded context. I think that doesn't make a lot of sense. Now the question becomes, what's the other alternative to build systems? And the other alternative that I see quite frequently are something that I would call data modules. So we could look at that e-commerce system and we could say, well, obviously there are customers, there are products, and there are orders. Now we have some problems because the customer for an invoice would be my employer, SwagLab GmbH, while the customer for the delivery, so if the company orders a laptop for myself, it should be delivered to my home. It should not be delivered to SwagLab GmbH. So there are actually two different customers here. The one that actually gets the product, myself, and the one that pays the whole thing, which is that entity, SwagLab GmbH. And I'm not sure how to build a uniform model for that. You would have to say, okay, well, Eberhard is an employee of SwagLab GmbH, SwagLab is the employer, and somehow there are some relations. I don't want to go there. And there is another problem here. So what will this system actually do? Well, it needs to support a customer who orders a product. It needs to create an invoice for a customer for an order of a product. A product needs to be delivered to a customer because of an order. So anything that this system does, or at least quite a few things, depend on customer, product, and order, which is not that surprising. So if we have these three modules, almost everything will depend on these. So there is a problem here, because if we build these things and we want to build something like logic for shipping stuff, well, we need to have a relation to the customer, to the product, and to the order. And then we have this problem that shipping can only do its job when it has access to these three different pieces of data. So I would argue, if you really want to be autonomous, you want to have highly autonomous models that have everything to implement some piece of business logic, like invoicing. And that means that you have the customer and the product for invoicing in invoicing, and you have the customer and the product for shipping in shipping. That way, they are autonomous. They are pretty much can work on their own, because they have all the data inside their module. So this is what you actually want to do, in my opinion. And therefore, my advice would be to focus on functionality, not on data. So something like customer, that's data, that's not a great model. You should focus on autonomy, and the models that you create should include all the necessary data. And maybe this focus on autonomy is what helps you to actually find great models. I did some episode in my stream about this, and I apologize for that they are in German. So I did one about bounded context and what that actually is, and I did another one about how models relate to bounded context. And maybe this is something that you want to watch if you happen to know German. So the lesson learned here is bounded context has these three things to it: ubiquitous language, model, and team. And I think this is much too much. We should probably focus on building functionalities in modules. We should stay away from creating things that only handle some piece of data. And therefore, my conclusion of the talk is, well, domain-driven design is about letting the domain drive the design. Collaborative modeling is a way to facilitate collaboration, which is very important for software development. And maybe creating that artifact is a secondary goal. It's not the first priority. Bounded context, as I said, is about ubiquitous language, model, and team, which makes bounded context very complex. So maybe you want to focus on models, on highly autonomous models or modules instead. We did quite a few episodes about domain-driven design in the stream, so there is a lot to be learned there, and you can just watch them for free. If you have some specific questions, feel free to schedule a virtual coffee with me. So that's on Calendly, and you can just go ahead and schedule a 1-hour call with me for free. And if you are interested in this talk, here is a QR code that takes you to OneDrive where you can download the slides. If you don't want to use that, you can also send an email to WeAreDevs2025, and then you get a link to that OneDrive that runs on Amazon Lambda, so your email address will be locked for 14 days. And if you do some error on your email address, I will handle that manually. So thanks a lot. Thanks a lot for listening. And I'm actually a minute early, so thanks a lot.